Hi students, in the previous class we discussed the introduction to correlation and regression. Where is correlation used and where is regression used? What is the purpose between, or what is the difference between correlation and regression? Where is correlation used and where is regression used? Okay, now in this topic we will be studying, in today's video we will be studying about correlation analysis, which are the different measures of correlation, which are means how can we find out correlation between the two variables given to us. Okay, so let us begin the class. So first, what is correlation analysis? Okay, and what is it used for? Correlation analysis, as we discussed in the previous class, is used to determine the degree of relationship or association between two or more variables. Okay, what is correlation analysis? It is used to determine the degree of relationship. Okay, it is used to determine the degree of relationship or association between the two or more variables. Okay, correlation expresses rates of relationship between groups, but not between individual items. Okay, so it will express the relation between two groups of items, like the X group and the Y group, not between one X and one Y. Okay, it should be in groups. That is what we understand here. Next, which are the different types of correlation? We have discussed that we can have one variable and the other variable, and there may be, it is possible that if one variable increases, the other variable changes. Okay, that is when there is a change in one variable, there is a change in the second variable accompanied to it. Okay, so then in that case we say that they are correlated. Now the direction of correlation will decide what kind of correlation it is. Okay, so for example, if one is increasing and the other is also simultaneously increasing, okay, the other one also shows increase, then in that case we say that there is a direct or positive correlation. Otherwise, when we say that they are inversely related to each other, like say if one variable is increasing, the other variable is decreasing, in that case we will say that they are negatively correlated. Okay, so simultaneously increasing, we will say positive correlation, or else if they are going in opposite directions, then we say that they are negatively correlated. Now in some cases, the variation in one of the observations may or may not produce any kind of result in the other variable. So in that case we say that it is of no correlation. Okay, in case if they are related, there will be a change in any one particular direction. Okay, what is there here? That while studying two variables at the same time, it is found that the change in one variable is accompanied by a corresponding change in the other variable, either directly or inversely. Then the two variables are said to be associated or correlated. Otherwise, we say that they are not correlated. Okay, അതിനെക്കുറിച്ച് നമ്മൾ പിന്നെ സംസാരിക്കാം. So ഓരോന്ന് എങ്ങനെയാണ്, what is positive correlation, what is negative correlation? Let us discuss. So first thing, positive correlation. If two variables move in the same direction, okay, either when one is increasing, the other is also increasing. When the first one is decreasing, the second one is also decreasing. In that case, we say that they are moving in the same direction. So in that case, we say that it is positive correlation. Okay, some example is that we shall take first example as the height and weight of a growing child. Clearly, the height is increasing. As the height increases, the weight increases for a particular case of growing child. Okay, not for any other cases, normal cases. Now in the same way, normal case for yield and rainfall, when there is a good rainfall, we will have a good harvest. Otherwise, the harvest or the yield may be affected by less rainfall. Okay, so if the rainfall is increasing, we may have a good harvest. Otherwise, when the rainfall is decreasing, we will have less yield. Okay, same way, profit and investment. If you invest more, you may have the chance to earn more profit. Same way, if you invest less, you will be getting less profit. So these two are again related to each other positively. Okay, so height and weight, as height increases, the weight also increases. When the rainfall increases, the yield also increases or decreases. When one increases, when one decreases, the other one also decreases. Okay, movement is in the same direction. Okay, either like this. Profit and investment. If profit is increasing, the investment should also, to increase profit, we need to invest more. Same way, if you invest less, you will have less profit. That is again positive correlation. Examples of positive correlation. Okay. Same way, we shall move on to next, negative correlation. If two variables move in the opposite directions, they move in the opposite directions. When one is increasing, the other is decreasing, or when one is decreasing, the other is increasing. So, in that case, we say that the correlation between the variables is negative. Okay, they are negatively correlated. So, we can have an example of price and demand. Okay, the two variables are price and demand. When the price increases, the demand of the item decreases. We are talking about regular commodities. Okay. There are exceptions in some cases. When the price increases, the demand increases. When the demand decreases, and when the price decreases, the demand increases. Okay. So, this is the price demand law. Now, the profits of insurance company and the number of claims it has to meet. For example, if there are more claims, then obviously the profits will be less. Okay. We have heard that if more the number of claims, less the profit for the insurance company, because if there is a claim, they have to pay the complete amount. Okay. So, otherwise they don't have to pay the complete amount. So, these are some examples for negative correlation. You may find out more examples. Next, what is no correlation? Okay, when the two variables are known to be, uncorrelated, if the movement on one part of the variable, movement on the one variable does not produce any movement on the other variable in a particular direction. That is, when this increases, when x increases, we can't say whether y is going to increase or it is going to decrease, or whether it is increasing or decreasing. Means there is no certainty, right? For example, if the shoe size of a person increases, can you say that the intelligence of that person also increases? No, they are totally unrelated variables, right? Shoe size is one variable which is not at all related to the intelligence of the person. Okay. So, now let us discuss some algebraic method of finding out correlation, some mathematical calculation based methods to find out correlation between two variables. Okay. So, they are scatter diagram. First one is by looking at the diagram, graphical method. Okay, scatter diagram. Second one is Karl Pearson's product moment correlation coefficient. It is also known as coefficient of correlation. Okay, Karl Pearson's product moment correlation coefficient, or correlation coefficient, or coefficient of correlation. Okay, next one is Spearman's rank correlation coefficient. Spearman's rank correlation coefficient, and then we have the coefficient of concurrent deviations. Okay. See, Karl Pearson's product moment correlation coefficient is generally used for quantitative data. Okay, quantitative data, and Spearman's rank correlation coefficient is used for qualitative data. Okay, qualitative characteristics. If both variables are qualitative and we are comparing the two qualities, in that case we may use Spearman's rank correlation coefficient. And the coefficient of concurrent deviation is just to get an idea about the measure of correlation. Okay. So, we shall take one by one each one of them. Okay. Let us first discuss what is a scatter diagram. Okay. Scatter diagram is nothing else but a graphical method of showing correlation between the two variables. Okay. We shall plot the values x and y. If you take x and y as shown in the previous video, we collect the data and we just prepare a scatter plot. Okay. And then try to connect them using a graph or a line or something. So, we can understand how the points are moving. Okay. Now, there are 4 different types of possibilities. Okay. Let us see each one of them. So, there are 2 ways where we can have a positive correlation. Okay. If as x increases, the y also increases. We can see from the graph itself, from the scatter points itself. Say, let me bring this down here. Suppose if we are having the y axis like this and the x axis like this. Okay. Now, as x is increasing, we may have the plot, say, one point is here, 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 one here, then one may be here, then one may be here, here and here. What can we observe from this? We can clearly observe that it shows a positive development. That is, when x is high, y is also high, right? When x is low, y is also low. When x is high, y is also high, and when y is low, x is also low. Okay, so it shows an increase either this way or this way, like that. Okay, it may be in any direction, but it shows an increased change in the other variable with respect to the other variable, first variable. Okay, when x is increasing, y is also increasing. This is what we can observe from this. Now, what happens if say this is x axis, this is y axis, when x, this is y. Okay, now if all the points are on the straight line, if all the points on the straight line are such that, say, we can connect them like this, okay, and also that when one is increasing, the other one is also increasing. Okay, in that case, we say that it is a perfect positive correlation. Okay, we say that it is a perfect positive correlation. Also, that when there is a small change in x, y also changes by the same amount. Say, for example, if x increases from 1 to 2, x increases from 1 to 2, y also increases from 1 to 2. Or we can say that if x increases from 3 to 9, so 3 to 4, y also increases from, what is the change? Change is 1 unit, right? Same way, y also changes, the change in y also will be 1 unit. So that is what we mean by perfect positive. This is called perfect positive. This is perfect positive correlation. We have written here perfect positive correlation. When they are a little bit random but still showing positive correlation, we say that it is a positive correlation. Okay, so here we can observe that the correlation coefficient is generally denoted by r, and what we can observe is that the value of r always, in case of positive correlation, lies between 0 and 1, not 0, not 1. If it is positive, lying between 0 and 1, we say that it is positive correlation. But if it is equal to 1, we say that it is showing perfect positive correlation. The line will be a straight line. Okay, the change in x will be equivalent to change in y. Okay, same way for negative correlation, it will be the other way around. Okay, the points are downwards. When x is increasing, y is decreasing. The value of y is decreasing. See, look at these 2 points. X was low, y is high. Look at this point. This point. In this point, what happens is when x is high, x is away from origin. Okay, so x is high, y is low. Correct. So this point shows that. So we can see that there is a negative or decreasing trend. Okay, so we say that the correlation coefficient r lies between -1 to 0. It is negative. Okay, but lies between -1 to 0, not -1, not 0. Okay, same way, if it follows a straight line, if the points all the points follow a straight line, we can have a perfect negative correlation. Okay, scatter diagram. What is a scatter diagram? In the scatter diagram, we can see that there is no correlation between the 2 observations. Okay, what happens in this case? See, the points are not at all related. We can't say whether it is increasing or whether it is decreasing. See, say for example, let me draw something and show it to you. Let me take the x-axis and this is the y-axis. Okay, now this is x and this is y. Y. Now, sometimes when x is here, you will get a point here. Sometimes when x is a little bit more, we can have something here, and then it may be very high or very low, again very high or very low. We can't say anything about the set of points, how the points are moving. The y is not at all related to x, or it may be given in any order. In that case, we say that there is no correlation between x and y. Okay, the change in y is not dependent on change in x. In that case, we say that there is no correlation between x and y. Okay, sometimes the graph or the curve may show like this. First it is increasing and then it will show a decreasing trend, or sometimes it shows a decreasing trend and then an increasing trend, or it may be a proper curve V shape. In that case we say that it is a curvilinear correlation, but still we say that there is no correlation. Okay, we can't say whether see, as to have correlation, the second variable, the dependent variable, should move in the same direction. Should move in any one particular direction, not same, either same or opposite, but it should move in only one particular direction. When x is increasing, y should either increase or it should decrease. It should not happen that sometimes y is increasing and sometimes y is decreasing. To have correlation, here sometimes y is increasing and sometimes y is decreasing when x is increasing. In that case we say that r is 0. So, we have a curvilinear correlation. Okay. Now, scatter diagram has some kind of limitations. So, let us discuss that. We can have an idea about the direction of correlation only. Okay, in scatter diagram or with the help of scatter diagram, we can just have an idea. We can just have an idea about the direction of correlation, and also whether it is high or low, whether there is a good amount of correlation between the two variables or there is a low amount of correlation between the two variables. But we cannot know how much or by what degree they are related to each other. Okay, we cannot exactly determine the degree of correlation. We cannot determine the level, the exact degree of correlation. We can just know the direction of correlation. Okay, or whether it is high or whether it is low. We cannot know the exact degree of the correlation. These are the limitations of scatter diagram. But we can know the exact degree of correlation between the two variables using some other measures. So, let us go into Karl Pearson's product moment correlation coefficient. Okay, what is this? This is Karl Pearson's product moment correlation coefficient. It is the best method. It is taken as the best method to find correlation between two variables, and it is defined as Karl Pearson's coefficient of correlation, or correlation coefficient is defined as the ratio of covariance between the two variables, to the product of standard deviations of the two variables. Okay, that is, it is denoted by R. It is denoted by R, or when we are talking about two variables x and y, the correlation coefficient R xy. Okay, so therefore R is equal to correlation coefficient R will be equal to we can also write it as Rxy, which is equal to COV of x comma y, that is covariance of x and y divided by standard deviation of x into standard deviation of y. This formula is a very important question. So, this formula is very important formula to find the Karl Pearson's correlation coefficient. It is defined as covariance of xy divided by standard deviation of x into standard deviation of y. Okay. Now, if the two variables are denoted by x and y, and if the corresponding bivariate data are xi, yi, which is equal to I equal to 1, 2, 3 up to n, that is, we can have n different values, n different pairs of x and y, okay, n different pairs of x and y, then the coefficient of correlation between x and y due to the Karl Pearson's is given by this formula. We have discussed this. Okay. Now, where we know that what is coefficient of covariance of xy, covariance of x and y is defined as sum of xi minus x bar into yi minus y bar divided by n, or we have a short formula as sigma xi yi by n minus x bar y bar. Okay, that is sigma xi yi by n minus x bar y bar. Okay, now we already know what is standard deviation of x and standard deviation of y. Individually we need to find out s of x and s of y. These are the two different formulas which we already know how to find. Okay, we have studied that in the previous class, previous videos. Next, this is a consolidated formula. Okay, there are many things to calculate here, but instead, if you use this formula, we can directly find out the correlation coefficient. So, this formula is preferred. We shall be solving problems based on this formula to find out the Karl Pearson's coefficient of correlation by the given conditions. Let us see. This is n Rxy is equal to n into sigma xi yi, or product of the variables, the sum of product of variables minus sigma xi into sigma yi divided by under root of n into sigma xi square minus sigma yi the whole square, under root of again n into sigma yi square minus sigma yi whole square. Okay. So, let us understand this formula by taking an example. First example, suppose we need not calculate all these values, but we shall use the formula and learn how to use the formulas. The values are given like this. Okay, compute the correlation coefficient between x and y from the following data. Here from the data, these values have been calculated and placed and given to you. So, now we just need to learn how to use the formula. Okay, so this is n is equal to 10, sigma xi yi or xy is equal to the sum of product of variables is equal to 220, then sigma xi square is equal to 200, sigma yi square is equal to 262, sigma x is equal to 40 and sigma y is equal to 50. Now, what we need to find is r. Okay, what is the formula to find r? The formula to find r is rxy is equal to n into sigma xi yi minus sigma xi into sigma yi divided by root of these values. Okay, so just let us try to put the values and calculate. Okay, so we have what is value of n? What the value of n is 10. So, we shall put 10 here. Then sigma xi yi, that is sigma xy, that is equal to 220. Okay, minus sigma xi into sigma yi. Where is sigma xi? Sigma xi is 40 into sigma yi, that is 50. Okay, divided by under root of square root of n into sigma xi square. N is 10. What is sigma xi square? Sigma xi is sum of squares of the variables. Okay, that is 200 minus sigma xi the whole square. Where is sigma xi? Sigma xi is 40. Okay, this is 40 the whole square. Same way, we shall into square root of n into yi square. What is n? N is equal to 10 into yi square is, what is yi square? Sigma yi square is 262, that is 262 minus 50 the whole square, minus 50 the whole square. When we calculate this, you know how to calculate all these values, right? When we calculate, what we get is, I shall directly write down the answer so that it can be, we can save time. Okay, so once we calculate, what we get here is 0.91. We get 0.91. Okay, so this is what we need to find here. Okay, so we have found out the value of rxy is equal to 0.91, and that is the correlation coefficient. Okay, so this is the very important formula which you need to learn by heart, how to find out Karl Pearson's correlation coefficient. Okay, Karl Pearson's correlation coefficient or coefficient of correlation. Let us go for the next problem. Okay, this here we have got the raw data. We have got x and y, and we need to find out all the values which we placed in the previous formula. So, let us see what is the formula and what all things we need to find. So, in this case, we have the formula is given here. So, what all things do we require? We first of all require sigma xi. We need to find out sigma yi. So, we shall write down x here. We shall write down x here, xi. Okay, and this is our yi. Okay, then we have xi square. Okay, we shall find out xi into yi, xi yi. Then we will find out xi square, and then we will find out yi square. Okay, and then we will find the sum here. Okay, so let us start doing the problem. Let us see how we can do this. Okay, so what we have here is x is given as 2, 3, 5, 5, 6, 8. Okay, When we add all these, we get 29 here. We get 29 here as the sum. Okay, we get 29 as the sum. We get 29 as the sum. Okay, now what we need to find out is xi square. Xi square, what is xi square? 2 2s are 4. We find out 4 here. We shall find out this is 4. So this is 3 3s are 9, 5 5s are 25. Again, what we have here is this was also 5. So we get 25. So this is 6, 6 are 36. Then for 8, 8 are 64. Then when we add all of them, what we get is 163. 163. Okay. Same way, we will put down the y's. What are the values of y? What are the values of y? Values of y are given as 9, 8, 8, 6, 5, 3. Okay. So this is 9, 8, 8, 6, 5, 3. When we add all of them, we get 39. What we get is 39. Okay. Let me draw this line here. This is the sum. Okay. This is the titles. Okay. Now we need to find the xi yi's. Xi yi's is 9 2s are 18. So what we have here is 18. Then 8 3s are 24. 8 5s are 40. 6 5s are 30. Then 6 5s are again 30. Okay, 8 3s are 24. We need to find out the sum of xi yi's also, because we need that here. Okay, so that is sigma xi yi. Sigma xi yi is 166. So we shall have 166. Same way, now we need to find out yi square. Yi square is 9 9s are here we have as 81. 8 8s are 64. 8 8s are 64. 6 6 are 36. 5 5s are 25, then 3 3s are 9. When we add all of them, we get 279. Okay, what we get here is 279. Okay, so what is this? This is sigma xi. This is sigma xi. This is sigma yi. This is sigma xi yi. Okay, this is sigma xi square. This is sigma yi square. So we have everything that we can put into this formula. So we shall just put that into the formula. What is n? N is 1, 2, 3, 4, 5, 6. There are 6 pairs. Okay. So we have n is equal to 6. Okay. So we shall put all these values. 6 into what is sigma xi yi? Sigma xi yi is 166. So 166 minus what is sigma xi? Sigma xi is 29 into sigma yi, that is 39. Okay, that is 29 into 39 divided by square root of n into what is n? N is equal to 6 into xi square. What is sigma xi square? What is sigma xi square? It is 163. Okay, 163 minus sigma xi whole square. Okay, where is sigma xi? Sigma xi is 29. So that is 29 whole square into square root of, again, what is this? This is n into sigma yi square. N into n is equal to 6 into sigma yi square. Sigma yi square is equal to 279. Okay, 279 minus sigma yi whole square. Where is sigma yi? Sigma yi whole square. Sigma yi is 39. So we have 39 whole square. When we calculate this, this is equal to minus 0.93 minus 0.93. That's it. So now let us see how to solve this problem using the conventional or original formula. Okay, so let us consider what is the formula. The formula to find R is equal to covariance of x comma y divided by standard deviation of x, that is sigma x into sigma y. Okay, this is the formula. So we need to find out covariance of x, and we need to find out standard deviation of x and standard deviation of y separately. Okay, so let us start solving. So now let us try to solve the problem. So here first thing is that we need to find out x bar. Okay, to find out standard deviation we need to find out x bar. So what is x bar? X bar will be equal to sigma xi by n. Okay, and that is equal to 6. So that is equal to 29 divided by 6, which will give you 4.833 and so on. Okay, and same way, what is sigma y or y bar is equal to sigma yi divided by n. What is sigma yi? It is 39. So it is 39 divided by 6, which will give you 6.50. Okay, so x bar is found out, y bar is found out. Now we shall find out covariance of xy. Okay, now we shall find out covariance of xy. What is covariance of x and y? That is given by sigma xi yi divided by n minus x bar into y bar. Okay, we shall put the values and simplify. What are the values? Let us look at the problem. So here the sigma xi yi was given to you as sigma xi yi is equal to 116. Okay, we shall put 116 here. This is 116 divided by 6 minus x bar is 4.833 into 6.50. Okay, so this is what we have, and once we calculate this thing, what we get here is minus 3.7498. Okay, so first what we do, we find x bar, we find y bar, and then we find covariance of xy, because we already have all other values here. Okay, the formula to find covariance of xy is given by sigma xi yi divided by n minus x bar into y bar. Okay, so that is the formula. Now what we need to find is the standard deviation of x, because we have the formula to find the correlation coefficient as covariance of xy divided by sigma x into sigma y. So now what is left is standard deviation of x and standard deviation of y. So let us find out standard deviation of x and standard deviation of y. Okay, so that is sigma x. What is, how to find sigma x? Sigma x will be equal to sigma xi square divided by n minus x bar square, the whole root. Okay, so that will be equal to, you put all the values, sigma xi square. What is sigma xi square? Sigma xi square is equal to 163. So 163 divided by, this is 163 divided by 6 minus, what is x bar? X bar is equal to 4.833, the whole square, the whole root. Okay, once we calculate that, what we get is 1.95. Okay, the same way we shall calculate sigma y. Sigma y is also equal to, what is sigma y? Sigma y, standard deviation of y is defined as sigma yi square divided by n minus x bar, sorry, y bar square, the whole root. Okay, that is equal to under root of, what is yi square? Sigma yi square. Sigma yi square is equal to 279. 279. This is 279 divided by 6 minus, what is this? Y bar. Y bar is given as 6.50. So we have 6.50 as our value into the whole square. Okay, when we calculate this, what we get here is 2.0616. Okay, now we will find out the covariance of x, y. Okay, so what we have here is covariance of x, y divided by covariance of xy divided by sigma x into sigma y, that is equal to the coefficient of correlation. Okay, correlation coefficient of x and y. So what we have here is covariance is minus 3.7498. What we have here is minus minus 3.7498 divided by 1.95 into 2.0616. Once we calculate this, what we get is minus 0.93. Again, the same value. Okay, so this is how we can calculate covariance, or R is equal to covariance of xy divided by sigma x into sigma y, and that is equal to minus 0.93.